All right, so this is going to be the video for the first unit test for chemistry. Okay, so we're going to kind of get through this. Usually nothing too crazy here. So we're going to start off with scientific notation. Okay, so when you're doing scientific notation, our goal is to get to a number between 1 and 10. It has to be a number between 1 and 10. Okay, so when we're starting with big numbers, okay, one of the things you're going to do is you're going to start from wherever the decimal would be. If it's not there, it would be right here. Okay, and you're going to go to the left until you get to a number between 1 and 10. So I'm going to go over 1, 2, 3 times gives me 5.8. So that's what I want. So 5.8 times 10. And then the way I remember this is if this were my bank account right here, so if that was your bank account, you'd be a pretty positive person. Okay, so if it's a big number, you get a positive exponent. If it's a small number, you'd be more of a negative person. Okay, so this would be a positive 3. Okay, we're going to do this one. We're going to start here. We're going to go left. 1, 2, 3, 4, 5 times. So that gives me 4.5 times 10 to the 5th. Okay, so the key thing here is make sure you are at a number between 1 and 10. Okay, so you're not going to do 45. You're not going to do 0.45. It has to be a number between 1 and 10. Okay, C, we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So that would be 3.02 times 10 to the 8th. And it has meters right here, so I'm going to keep that meters in my answer. So if you see units, put them in your answer. If you don't see them, then don't worry about it. Okay, on the next one, I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times. 8.61 times 10 to the 10th power. Okay, now we're going to do small numbers. Okay, same rule, has to be a number between 1 and 10. So we're going to start at the decimal. We're going to go to the right now. 1, 2, 3, 4 times. Okay, so 5.08 times 10, and this is a small number, so it's -4. Okay, next one. 1, 2, 3, 4, 5, 6, 7. Okay, so 4.5 times 10 to the -7. Next one is 1, 2, 3, 4. So 3.6. You could keep the zeros if you want. If you want to do 3.600, that's totally fine. Okay, or you could just do 3.6. Now I went to the right. 1, 2, 3, 4 times. So that's times 10 to the -4. Okay, next one, you're going to go to the right. 1, 2, 3 times. So that gives you just 4. You could put 4.0 if you want to. And you could just leave it as 4. 4 times 10 to the -3. Okay, so now we're going to go backwards. Okay, so the key thing here is look for your exponent. Okay, if this is a positive, that means it's going to be a big number. So I'm going to move that decimal to the right because I want it to get bigger. So we're going to go to the right. 1, 2, 3, 4, 5 times. That gives you 580,100. The next one, I see 8.12 times 10 to the 7th. So I'm going to write that right here so I've got more room. I'm going to go to the right since it's positive. 1, 2, 3, 4, 5, 6, 7, and you're just going to fill in zeros wherever there's a blank. Okay, so that's going to give me 81,200,000. Okay, going over here. Okay, this is going to be a -3. Okay, I know it's kind of hard to see on mine. I believe it's that. Yep, -3. Okay, 5.0 times 10 to, I think that's -2. Okay, that was a little bit blurry on my picture. Okay, so the key thing here, this is a -2, so I'm going to go to the left since it's a small number. Okay, so I want it to get smaller. If it's negative, it's a small number. If you move it to the right, it's going to get bigger. Okay, so move it to the left 2 times. 1, 2. Okay, so my decimal is here now, so I'm going to fill in that 0. So I'm going to be 0.050. Okay, next one is 2.110 times 10 to the -3. Okay, so it's a -3, so I'm going to move it to the left. 1, 2, 3 times. So my decimal's here, fill in the blanks. So 0.002110. Okay. All right, the next part, this is the multiplication part. So this is not going to be on the test, okay? My thing here is you're going to have a calculator in this class. So whenever you're doing these, my main tip is there's 2 ways you can type this in. Okay, you can do it like this, where you could do 5.3 times 10 to the 6. A lot of people, it'll look like this in the calculator. They'll do 5.3 times 10, and they'll do like the little arrow thing, and then do the 6. Now, here's the issue is on a calculator, if you don't put this in parentheses, if you just go right into times 3.0 times 10 to the exponent of 2, your calculator is going to get confused. Okay, it's going to, even though you typed it in all right, okay, it's going to get confused on order of operations and you're going to get a wrong answer. So my number one tip for doing any of this stuff in the calculator, even though this is not going to be on the test right now, is put everything in parentheses, and that will keep it all cleaned. Okay, so that's my big thing, my big takeaway. Anytime you do a multiplication or division with scientific notation, put everything in parentheses. You cannot have too many parentheses. Okay, so that's my main tip there. So I'm not going to go really into this section since it's not going to be on the test. We're going to skip right on. Okay, so SI units. Okay, so SI units are units that scientists use across the globe to make sure if you're doing scientific experiments, it keeps everybody using the same unit. So that way we're not doing feet over here in the US and someone's doing meter over in the Europe somewhere. Okay, so whenever you see actual legit scientists, they're using these SI units, and I would know these. Okay, for length, it is going to be a meter. Okay, and the symbol is going to be little m. Mass is kilogram. Okay, so be careful of that. It is not gram, it's kilogram. Okay, because grams are very small. Okay, so a lot of times you're doing experiments and stuff, it would be better to be in kilograms. Time, that's an easy one. That's just going to be in seconds, and that's just S. Okay, volume is liters. Okay, or you could say meters cubed. Okay, so either one is fine, but liter works. Okay, that's just easier. You can just do L. And then Kelvin is your temperature. Okay, and that's going to be a big K. Okay, so we'll worry about Kelvin more, but I would know these because on the test, I could ask which of the following is an SI unit. Okay, and then if it's not on this list, that ain't it. Okay, moving on to the next part. Okay, talking about kind of metric scale stuff. So when you're looking at metric scales, okay, so if I was doing metric scales, you have tera, giga, mega, kilo, and then the great mighty King Hector, then hecto, and then deca, and then your base unit. Then you have deci, centi, milli, micro, I believe so. That by drinking chocolate milk under no particular fashion. So nano, pico, and femto. Okay, so your base, that is your 10 to the 0. Okay, that's like your starting point. Okay, and then as you go to the left, it gets bigger. So this would be 10 to the 1. This would be 10 to the 2, 10 to the 3, 10 to the 6th, 10 to the 9th, and 10 to the 12th. Okay, when you're going to the right, it's going to get small. So now you have negative exponents. So 10 to the negative 1, 10 to the negative 2, 10 to the negative 3, 10 to the negative 4. Oh, I'm sorry, not 4. That was my bad. 10 to the negative 6, 10 to the negative 9, 10 to the negative 12, and 10 to the negative 15. Now, very rarely you're going to go very big. You're not going to go into really tera and giga or pico or femto very much. Okay, I would say I'd be really comfortable with kilo to milli because that is your main thing here. Okay, so when we're looking at milli, okay, milli, your abbreviation for milli, okay, it would just be M. Okay, so if I was doing like milligrams, it would be like mg. Okay, power of 10 notation, it would just be 10 to the negative 3. Okay, now if you were doing like a base, let's just say our base is like 1. Okay, and you have milli, okay, 1 milligram, so 1 gram equals 1,000 milligrams. Okay, because milli are small. Okay, so 1 milligram, it takes 1,000 milligrams to make 1 gram. Okay, so my expanded notation would look like 0.001. Okay, because it takes 1,000 of them to fit in 1 gram. Base. Okay, there is no abbreviation for base. So if I just see gram and I don't see a prefix here, a lot of people get confused on base. If you do not see a prefix, so let's say I had like milliseconds, that would be milliseconds. But if I just see an S and there's nothing there, that's base. That's 10 to the 0. Okay, so if you see anything without a prefix, okay, that is your base. So that means that you're right in the middle with a power of 10 to the 0. Okay, so that would just be like 1 gram. Okay, so kilo is very big. So the abbreviation for kilo is K, little k. So that would be like something like kilogram. And your power of notation is 10 to the third. That's a positive 3. Okay, kilo is big, so 1 kilogram equals 1,000 grams. Okay, so you would put 1,000 here. Okay, I would get real comfortable with knowing, because you're going to see a lot of kilo and a lot of milli. Okay, so I would get really comfortable with knowing that 1 kilo equals 1,000. So if you run a 5K, like a 5-kilometer race, that's 5,000 meters. Okay, and milli is very small. It takes 1,000 milligrams to fit into 1 gram. So I would just get really comfortable doing that. Okay, so now we're going to do some conversions. We're going to convert 3,644 millimeters to meters. So I'm going to show you the decimal way because that's probably the easiest for doing these small ones. Okay, so milli is 10 to the negative 3. Meters, so I don't see a prefix there, so that's my base, 10 to the 0. So then you would look on your metric scale. Where is milli? Okay, and then where is meters? Okay, so milli's going to start onto the right. But if you're going 2 meters, you're going to have to go to the left. Now I would see how many times does it take me to get from milli to base. Okay, so how many spots does it take to get from negative 3 to 0? Well, that's 3. So you're going to move that decimal to the left 3 times. Okay, so if I had 3,644, okay, my decimal would be here. So I'll move it to the left 3 times. So 1, 2, 3. Okay, so that gives me 3.644 meters. Okay, which that should make sense because remember we talked about millimeters are small. It takes 1,000 millimeters just to fit in 1 meter. So if I have 3,644, you honestly don't even need to do conversions if you know this. Okay, you would just know that you get 3.644 meters. Okay, B, 74.5 kilometers, that's 10 to the positive 3 to meters, so no prefix again, so that's 10 to the 0. Okay, so now you're going from kilo to meters. So that means you're going to the right by 3. Okay, the way I'm looking at that is just where is kilo on your metric scale, which you'll get on a test, and where is your base, okay, and you're going from kilo to base, so that means you have to go to the right 3 times. So 74.5, I'm going to move that decimal to the right 3 times, 1, 2, 3, and that gives me 74,500 meters. Again, should make sense. 1 kilometer equals 1,000 meters, so just multiply that by 1,000, and you get that. Convert 3.4 kilograms to grams. Okay, so kilo is 10 to the 3. Grams is your base, so 10 to the 0. We're doing to the right again 3 times. So 3.4, move it to the right. 1, 2, 3. Okay, so I get 3,400 grams. Last one, 536 meters. So no prefix, that's 10 to the 0 to kilometers. So that's 10 to the 3. So I'm going to the left 3 times, so 536. The decimal would be right here, so you move to the left. 1, oops, it's being all weird. 1, 2, 3. That's 0.536 kilometers. Okay, moving on to physical and chemical properties. So the main thing here is physical properties are things that you observe without actually changing the substance at all. Chemical is if it reacts with something, if like it burns, things like that, that means you're going to change it to where it can't go back. Okay, so if I were looking at this blue color, okay, that's just something I see, nothing's changing, so this would be a physical property. Density, that's just how dense an object is. If I cut an object in half, okay, it's still going to be the same density. Okay, so nothing's changing. So if I had an aluminum block and I cut it in half, it's still an aluminum block, so nothing changed. So that's a physical property. Flammability, burns. Once something burns, it does not go back, so that's chemical. Solubility, it dissolves. Okay, if I were to dump salt into the water, I would just get salt water. Okay, the salt's not changing, it's just in the water now. Okay, so this would be a physical property because I could get the salt back out. If I just boiled the water, okay, I would be able to separate it and nothing changed. Reacts with acid, that's a dead giveaway. If you ever see any word that says reacts, that is a chemical property. Okay, anything that reacts with acid is not going to be able to go back. Supports combustion, that means blowing up. Okay, pretty hard to put something back together once it blows up. Okay, so that is chemical. Okay, sour taste. Okay, so people think of taste and like, oh, that has to be chemical. Okay, if I taste salt, it's just going to still be salt, nothing changed. Okay, so that is going to be physical. Melting point. Okay, difference between burning and stuff and melting. Okay, if I melt butter, okay, it's still going to be butter. Okay, so that's physical. Reacts with water. There's that key word right there, so that's chemical. Hardness. Okay, nothing's changing, like steel. Okay, that would be a physical property. Boiling point. Okay, if I boil water, even if it turns into a gas, okay, like a vapor, okay, it's still water. Okay, because I could condense it right back down into a liquid form if I got it cold enough. So this is physical. Luster is basically how well it shines, so that is physical. Odor, that is physical. Now, if you were to mix something and create a new odor, okay, like if I start burning something and it starts creating a new odor, that would be chemical. But odor by itself, that's just physical. Reacts with air. Again, reacts, that's chemical. Okay, going to next, physical versus chemical change. Okay, so again, we're looking for the same thing. Okay, if you can go back to the way you were before, okay, that's physical. If you're changing it into a new substance where there is no going back, okay, that is chemical. So if I take table salt and dissolve it in water, again, we said we could just boil the water, get the salt right back out, okay, that is physical. AG, silver tarnishes. That means silver basically starts to kind of rust and change color over time. Okay, there's no going back from that. Okay, that is going to be your chemical. An apple is cut. Apple's still an apple, that's physical. Heat changes H2O to steam. Okay, steam is still H2O. Okay, it's just in a different state. Okay, so that would be physical. Baking soda reacts with vinegar. Again, keyword right there, reacts. That is chemical. Iron rusts. Okay, if you start getting rust on your car or something like that, rust is no bueno. There is no just getting it back. You'd have to cut it out, put in new metal. Okay, so rust is no go. You can't go back, so that is chemical. Alcohol evaporates. So evaporates is just changing state. Okay, so that's physical. Ice melts. Okay, you just went from solid to a liquid, still water, so that's physical. Milk sours. We all know you can't go back. Okay, so that's chemical. Sugar dissolves in water, so just dissolves. Okay, no reacts, anything like that. I could still separate it if I just boil it, so that's physical. Wood rots. Trees can't go back. Okay, so that's chemical. Pancakes cook. Okay, you cannot turn it back into batter. Okay, so that is chemical. Grass grows. Okay, this is kind of a weird one, but you'd think it's physical because it's just still grass and stuff, but as grass grows, it goes through an aging process, and we all know aging can't go backwards, so that is actually chemical. A tire is inflated. Okay, nothing's changed. Air is still the same, tire is still the same. That is physical. Food is digested. Okay, if I puke it back up, it's not going to be the same. Okay, that is definitely going to be chemical. And paper towel absorbs your water. That is going to be physical. Okay, going to the next part. If you change the way something looks but haven't made a new substance, again, this is talking about physical and chemical again. Okay, so we're doing it again. So more practice here. An ice cube is placed in the sun. Later, there's a puddle. The puddle is gone. Again, you just change states. That is physical. Two chemicals are mixed together and a gas is produced. So something new is produced. Okay, so you have two different chemicals and you create a gas. This is not just you boiling it and creating a gas. You're creating something, so that is chemical. A bicycle changes color as it rusts. So rusts, can't go back. That is chemical. A solid is crushed to powder. Still the same substance. If you crush down pepper, it's still pepper. That is physical. Two substances are mixed and a light is produced. That's like a glow stick. Okay, you mix those chemicals in a glow stick. We all know that it all burns out and it won't come back. Okay, it's not going to glow again, so that is chemical. A piece of ice melts and reacts with sodium. Now, this would start off as physical. Okay, ice is just melting. But as soon as I saw that reacts with sodium, that's chemical. Mixing salt and pepper, I could still separate them. It would be a pain in the butt, but I could still separate them. Okay, nothing changed. Chocolate syrup is dissolved in milk. Okay, so it just dissolves. Nothing. It's be a pain in the butt to separate it, but you still could. Okay, nothing really changed. You just add chocolate to milk. Nothing's reacting. Nothing's getting produced. Okay, so this is physical. A marshmallow is toasted over a campfire. That's something burning. Okay, so that is chemical. A marshmallow is cut in half. Still a marshmallow. That is physical. Okay, next part, true or false. Okay, changing the size and shapes of pieces of wood would be a chemical change. Okay, so if I'm not burning it and stuff, I'm just cutting it into pieces, that would just be physical. Okay, so that would be false. A physical change, the makeup of the matter is changed. No. Okay, physical, the makeup still stays the same. Nothing is changing, so that part's wrong right there. Okay, so that would be false. Evaporation occurs when a liquid water changes into a gas. So again, it's just changing states. It's not, nothing's reacting. So this would be, okay, this would be true. Evaporation is a physical change. That is true. Okay, burning wood is a physical change. Nope, that is a chemical change. That is false. Combining hydrogen and oxygen to make water is a physical change. Okay, so if you're combining something, so if you're making something new, okay, hydrogen and oxygen is now going to become H2O. Okay, now could you theoretically separate hydrogen and oxygen? Yes, that's a very hard thing to do. Okay, so for the sake of this argument, we're going to say this is chemical because you're making something new and it is incredibly difficult to go back the way it was. Okay, breaking up concrete is a physical change. That is true. Oh, I'm sorry, that number 6 should have been, so this would be false, so number 6 would be false. I think I get stuck in the chemical thing. Sand being washed out to sea from the beach is a chemical change. Nope, sand's still sand, it's just chilling in the water. Okay, so that would be false. Okay, when ice cream melts, a chemical change occurs. No, makes a mess, but it's still just melting. It's still ice cream, it's just not, if you were to stick it back in the freezer, it would just turn back into, I mean, it's all still ice cream, it's just the state it's in. Okay, so this would be false. Acid rain damaging a marble statue is a physical change. Acid rain. Okay, and it's damaging the marble statue, so you're not going to get that marble back. So this would not be a physical change. That would be a chemical change. That is false. Okay, going down here to pictograms. Okay, so easy one. Okay, this is just flammability. Okay, how well does it react with, or well does it burn? Okay, you see the little symbol where something is being poured on the hand or metal and it's going away. That means it's corrosive. Okay, if you see like a dead tree and a dead fish, that means it's hazardous to the environment. And bear with me with my handwriting on here. It's not easy writing with a stylus. Okay, number 4, it looks like something's breaking apart, so that is going to be explosive. Skull and crossbones, that one's easy. Okay, acute toxicity basically means death, so it means don't eat it. Okay, if I see it looks like a gas tank, okay, that just means gas under pressure. Okay, I see this little, you see these like in zombie films and stuff like that, just means usually biohazard. Okay, so you're dealing with something that's not very good. Okay, this one's usually the tough one. It's got basically a flame on top of the little O. That means it's an oxidizer. Okay, so that means basically, fire needs oxygen, right? Okay, so that's why I remember that. And then if you see the little person with the chest and things are kind of going all in places, different places in the body, okay, this means it's a carcinogen. Okay, so basically can create things like cancer or a respiratory hazard. That one's usually an easy one because you're right there at the lungs. Okay, moving on to the last bit. So I'm not going to write these stuff down. Let's just kind of look and see what's going on. Let's look at this one girl here. Okay, 1, she is reacting something, looks like acid right there, and she's pouring something into it. 1, I do not see goggles at all. I do not see her hair pulled back. I see long sleeves. Okay, I do not see an apron. Okay, lots of things going on here. Okay, so basically, those are your main takeaways is you should wear eye protection, apron, girls, keep your hair back. You do not want loose, long clothing. Okay, looking at the next one, okay, going down, okay, it looks like you've got people playing in the lab, okay, so that would be a no-go on horse playing, especially if you have chemicals. I see no goggles, no hair being pulled back, okay, so a lot of things going wrong here. Then you have this person down here who apparently is an idiot, okay, and they're using a beaker to drink milk, okay, so if that happens to you, that's honestly your mistake, okay, so I would not use anything in the lab to eat or drink out of, okay, I don't see any goggles, okay, even though I don't think they're even doing a lab, I don't know, looks like they're just eating at a lab and just using a beaker, okay, so don't do that, so don't be dumb. Okay, the next one, I do see this girl, she has goggles on at least, I don't see an apron, hair, doesn't seem to be an issue. I'd probably still try to pull it back. But what I'm seeing is she's heating this tube up right here. And the tube is facing her. So if that thing were to react and blow, okay, she's not going to have a very nice face anymore, okay? Because if that's acid or anything like that, that's going to be not a good day for her. Okay, looking at this next one, It looks like goggles are on. I see like some long sleeves here. Okay, those could probably go back. Okay, so apron, that kind of thing. I see on the key it says sitting. Okay, honestly, I don't think sitting is really much of an issue. Okay, if I would just be careful, I would not. If you're heating this up right here, I would probably not be as close as he is, just in case. So just be smart. Okay, next person. Okay, I don't see hair tied back. Okay, she doesn't have her hair tied back. Doesn't look like goggles. Those look like glasses to me. Okay, so we got lots of things going on here. She's sniffing a chemical, so I don't know why you're doing that. Okay, pretty much we'll never sniff anything in here. Okay, even if you were to smell something, you never directly smell. You do more of a wafting. Okay, but that is very rare and stuff, and I doubt we'll do that in here at all. Okay, so the moral of the story is don't be an idiot. Okay, just when you're looking at answers, just go with common sense. Okay, that'll finish the review.